Section 4.2, the periodic table. The periodic table organizes 118 elements into groups with similar properties and places them in order of atomic number, in order of increasing proton number. Some people think it's in order of increasing atomic mass, but if that were the case, there's just a couple that's out of place there. So it does place them in order of increasing atomic number. So our learning goal for this section is to identify the group and the period of an element, identify the element as a metal, a non-metal, or a metalloid. So in 1869, about 150 years ago, Dmitri Mendeleev is credited with creating the periodic table. There were various people coming up with different ideas, and his kind of stuck. The thing about his is, even though all the elements had not been discovered back 150 years ago, he thought, okay, let's arrange the elements he grouped the elements with groups that had similar properties, and he also arranged the elements by increasing atomic mass, which now they had to tweak that. It's now arranged by increasing atomic number, but he left plenty of spots for elements to be discovered, and he would predict that, oh, there should be an element that is right here in this one area, and it's going to have these particular properties. And that was actually what was so amazing about the table that he created, was all the empty spots that he actually created, and he left open and said, okay, a particular element should be found, and it's going to have such and such properties. I think that is the most amazing thing. And so here's the periodic table of today. His periodic table nowhere was close to this amount of elements. But I want us to look at this. We are going to need to know what periods are. So periods are the things that go across. We would call them rows. So this is period 1. Here's period 2 with lithium, beryllium, boron, etc. over to neon. Here's period 3 with sodium and magnesium over there to argon, etc., etc. Now, families or groups are horizontal. They are vertical, i.e. up and down. I guess I got to remember which way is vertical myself here, okay? But those are groups. Now, certain groups have names that we need to know. So this group right here, alkali metals. Group number 2, alkaline earth. This area in here, transitionals. This area right here, the halogens. This group here, the noble gases. So, as I was just pointing out, the reason why I wanted to have that periodic table there was so that you could see them. But we just talked about that elements are arranged according to similar properties in vertical columns called groups. Now, periods are horizontal rows counted from the top to bottom as periods 1 through 7. And I already mentioned period 1 and period 2 and 3. Group numbers identify the vertical columns of the periodic table. They can be written in two ways. The letter A is used for the representative elements, 1A to 8A, and the letter B is for the transitional elements. So that's one way. So let's go back here to look at that. So here's our 1A, 2A, and then 3A, 4A, 5A. And that's if we're not even talking about the transitional elements. Or if we want to just number them 1 through 18, they are used for columns from left to right that way. To me, the 1 through 18 does not help us out one bit, but some people like to do it that way. All right, so here we go. Certain groups on the periodic table have common names, and that's what I was just talking about, so you need to know these. Our alkali metals here, alkaline earth, halogens, noble gases, this area right here is our transitional elements. So those representative elements, not the transitional, but the representatives, in group 1A called the alkali metals, and group 2A, the alkaline earth, which we just mentioned what they were, and group 7A is the halogens, and group 8A, the noble gases. So if we look at our alkali metals in group 1A, we look and see, here's our lithium, here's our sodium, here's our potassium. What's amazing about them is they have similar properties in the fact that if you put sodium or potassium metal in water, or or rubidiums, as you put them in water, they're reactive. And the farther down we go, the more reactive they'll be. They'll even like catch on fire, which is amazing that they catch on fire going into water. If we go over to the other side of our periodic table, on the right-hand side, we have the halogens, which are these gases. Green poisonous chlorine gas, our bromine, and our iodine, our purple iodine. So let's see. Identify the element that is described by each of the following. If we need group 7A, period 4. All right, well, we need a periodic table. First of all, group 7A, so we'll want to do 7A, period. So group 7A is over here, period 4. So here's period 1, 2, 3, and 4. So that's going to be our bromine. Next one, group 2A, period 3. Well, group 2A, period 3. Here's period 1, 2, and 3, so that's going to be magnesium. All right, group 5A, period 2. So here's group 5A, period 2. Well, here's our first period here, so our second period, that would be nitrogen. And then group 6B, period 4. So group 6B, period 4 is going to be our chromium. All right, so let's look to see, and yes, that's exactly what the solution says. Now, another portion of the periodic table divides them. There's this divided line here, this stair step. They call it a stair step case line. It divides metals from non-metals. And so if we look back to the periodic table here, you'll notice that our metals on the left-hand side of our stair step, except for hydrogen, of course. There's always an exception to just about every rule that we might say. So hydrogen we know is a gas, so of course it's not a metal, right? But on the right side of the stair step, there are our non-metals. But what about those elements, except for aluminium, that are right next to the stair step? There's a green here. What does that mean? Well, let's see what that means. They call them metalloids. And metalloids are on the zigzag line, and they exhibit characteristics of both metals and nonmetals. As we say that, except for aluminum right here. And why that's important is because sometimes you need something that acts both as a metal and a nonmetal. And so, for example, right here, right below carbon is silicon and germanium, and those are good in the semiconductor family because they kind of have both characteristics. So let's talk about metals. What kind of characteristics they have? They're shiny metals. They're shiny solids. They are ductile. They can be shaped into wires. They're malleable, meaning they can be hammered into a flat sheet. They're good conductors of electricity. They melt at a higher temperature than nonmetals, and they are solids at room temperature, except for the metal mercury. Now, nonmetals, like hydrogen and carbon and nitrogen, they are not shiny, and they're not ductile, nor are they malleable, and they're often poor conductors of heat and electricity. And they have low melting points and low density. So in other words, everything that metals were, nonmetals are not. Now then, as we look at metalloids, except for the aluminium, the elements along the zigzag line are metalloids. And so we look at the metalloids, and we notice that they're going to exhibit some properties typical of metals and some typical of nonmetals. They are better conductors of heat and electricity than nonmetals, but not as good as metals. They are semiconductors because they can be modified to function as conductors or as insulators. All right, so on table 4.3, it gives us some characteristics of a metal, a metalloid, and a nonmetal, which is just what we just talked about, and it gives it of our silver, which is a metal, and our sulfur over here, which is a nonmetal, and then here's our antimony, or antimony, however you want to say it, and you'll notice that it has some properties of both a metal and a nonmetal. So identify each of the following elements as metal, nonmetal, or metalloid. Well, you have to have a periodic table. So let's look at this. So sodium is right here, that's on the metal side, not a problem. Bromine is over here, that's a nonmetal. Boron, that's right here, so it's a metalloid. Manganese is right here, so that's a metal. And carbon is right here, so that's a nonmetal. So you'll notice that. Okay, so learning check, match the elements to the description. And so metals in group 4A, when we look at that, let me go back to this periodic table. In group 4A are right here. And so that would be our tin and our lead. And nonmetals in group 5A, let's go with, let me go back here, 5A. And our nonmetals would be our nitrogen and phosphorus. Okay. Our metalloids in group 4A. Here's group 4A. The two metalloids are silicon and germanium, which is what we just said if you look at the learning check. Here is an incredible periodic table. I have it where you can get to it without having to watch this video again, but you should maybe star this periodic table and save it in your favorites, because what's neat is it's going to tell you a lot about whatever you want. So let's say you want to know where the alkali metals are. Notice you click on our up here alkali metals and up comes yellow. If we want to click on alkaline earth, they pop over here. If we want to click on noble gases, they're right there. Well, let's say that we want to pick on, I don't know, what would be good? What about some mercury? Right here's mercury. Let's learn a little about mercury. Okay, so you'll notice that our mercury, it tells us a little bit about this. And we can click on it, we can learn all sorts of things. And then as we're reading, if we want to even learn more, we can, on some of the words that's even in here, it's going to tell us more. So the red pigment vermilion, so let's see what that is. Had to look that up. Wow. Anyway, so we can look at different things on this periodic table and use it for use along the way. So it's a nice table to be able to use. At the end of the chapter, we have a chemistry link to health that talks about the elements essential to health. And if you are into the nutrition areas or health areas, that's really important to know the 20 essential elements. Not that you have to know them and name them for this test. You don't. Okay, this is just a just kind of an FYI. Notice this macro, the bigger minerals, calcium and phosphorus and potassium and chlorine and sulfur and sodium and magnesium, are involved in the formation of bones and teeth and maintenance of heart and blood vessels, muscle contraction, nerve impulses, acid-base balance, and regulation of cellular metabolism. That's pretty important. And so here's a table that lists the exact things that are essential. Then there's the other essential elements called microminerals, or trace elements, that are only in small amounts. And so when we look again at table 4.4, here's our typical amounts of essential elements. And if you look at where they're placed on the periodic table, you can see that in our body doesn't need all the elements in the periodic table, but it has kind of all of these that are up here in this area.